Hello and welcome to a video for Intro to Computer Science. So today we're going to continue looking at Python. All right, we're specifically looking at chapter 4 from your textbook. And we're talking about looping with images. So using what's called a for loop to process an image using Python. All right, so I'm going to go through sort of these paper notes, but you're going to want to have REPL open. And there's a couple of links and files inside of the email that I've sent you that you're going to need to be able to follow along and do the activities that are inside of this packet. So again, I'm just going to go through sort of the written note part, but there's activities that you should be kind of doing as we go here. All right, so first things first. A review of sort of pictures and how they're stored in computers. So in the last unit, we know that a picture is made up of RGB values, red, green, and blue, and those can go from 0 to 255. So in essence, a picture is just a series of numbers that specify how much light to project at each pixel. All right, so you can think of a picture as just a grid of pixels. So each picture has an XY location in that grid. All right. Now, the first pixel in your picture is going to be at X equals 0, Y equals 0. All right. And then as you go to the right, X is going to get bigger, and so on and so forth for however large your picture is. All right, so these are always going to be your X, and they represent the columns. All right, so this would be column 0, column 1, column 2, column 3, and so on and so forth. All right, and then the same thing over here on the Ys. All right, they're going to go down. So the coordinates of the pixels are always going to be positive numbers. Because they go bigger as we go to the right, they get bigger as we go down, and the top left corner is our 0, 0. And again, these could keep going if you have a much larger picture, but they all represent sort of your Y values, and these represent your rows. So this would be row 0, row 1, row 2, row 3, row 4, and so on and so forth. So if we just pick a random pixel like this one right here, we would refer to this pixel and say, hey, this is pixel 1, 3, the same way we would on like a piece of graph paper in a math class. So pretty consistent with things you've seen before. The only difference is we're not really dealing with any negative indexes, and the top left corner is 0, 0. But from that, we can sort of identify any pixel that we want inside of our picture. Now, as far as how they're encoded, this is what I was just saying, it's the amount of red, the amount of green, and the amount of blue. So if you have a picture and there is a pixel that's black, all right, we know what's really being stored here is just a red value of 0, a green value of 0, a blue value of 0, which means the light is all off and you're getting the color black. Here, it's kind of hard to tell on the black and white, but if you've got it up on your computer, this would be something like red 255, green 255, and then blue 0. Right. Over here, we might have something like, red 0, green 255, blue 0. And then if you've got something that's just white, that's usually like red 255, green 255, blue 255. All right, so black is when everything is 0, white is when everything is at its max value of 255, and then we can get all sorts of different colors by modifying these and changing them. But a picture is broken down into pixels. Each of those pixels has a coordinate that tells us where it falls in the picture. And then each pixel also has a red, green, and blue value so that we know what color to actually display at that location. All right, so that's kind of the breakdown of how it's stored and what's inside of it. Now, what we're going to do now is a little activity just so that you can kind of see how this plays out with an actual image. So in your email and on Google Classroom, there is this caterpillar picture. So you can get it from either location. And then again, also in your email or on Google Classroom, there is going to be a link to this site. Okay. So what you're going to do is you're going to upload the picture to this site and you're going to explore it, because what this site's going to allow you to do is it's going to allow you to specify pixels inside of the picture. So look at specific pixels, and then it's going to give you information about the RGB values at those pixels. So there's different exercises here. What are the values in the yellow feet? What are the values in the white background? What are the values in the green leaf? What are the values at this specific pixel? So you want to take a moment and go through and do this. All right, I'm going to put down some answers, but your answers might be different. There's not like one set of answers here, but take the time, pause the video, go try this activity. All right, now that you've tried the activity, I'm just going to kind of tell you what I got, and hopefully yours are in the same ballpark. So I chose the coordinate 274, 54, which was one of the yellow feet. So that would be over 275 pixels, because remember, the first one is actually 0. So over 275 pixels, and then down 55 pixels, because again, the first one is a 0. So, if you're at row, let's make the numbers easier. If you're at row 1, technically that's the second row because there's a row 0. If you're at column 1, technically that's the second column because there's a column 0. So if I'm at 274 or 54, that means I actually went over 275 and I went down 55. But I ended up with an RGB value of 249, 255, and 0. So yellow is, mostly red, mostly green, and then no blue. Now, what you probably noticed if you clicked around it a little bit is that even when the color looked constant, these numbers might have fluctuated a tiny bit, like up or down 1 or 2 in either direction. And it's just that the difference is so small that our eye is not really able to tell the difference. So to us, it looks like one solid color, when in actuality, it might be, 1 or 2 different for like the red or the green component. All right. So what are the RGB values for the white background? Again, where you picked is irrelevant. I picked 295.10. But what you should have seen is that the white background was pretty consistently 255, 255, 255. You might have found something where one of these was a little lower, but generally white is going to just be all 3 of those sort of maxed out. What are the RGB values of a pixel in the green leaf? So again, I chose 173, 122, and there was a 1 for the red, a 255 for the green, and a 0 for the blue. So there might have been a tiny bit of red. Maybe you found one where the red was 0, but basically it's all green, which is what you would expect. And then finally, what are the RGB values of the pixel at location 387, which is sort of that black line that goes down the middle of the leaf. And hopefully what you should have found there, and this one you should have the same exact answer, is that all of those were just 0. So again, it's a nice little tool because it does show you that a picture is really just these individual points of color, and those colors are defined by the 3 different values of your red, your green, and your blue. All right. Now, if we go to the next sheet here, all right, this is another activity that you're going to do. All right, so you're going to use the link that I provide to the REPL. All right, that's going to open up a REPL, and as soon as you start typing in it, it'll make a copy that will only exist in your account. So make sure you're signed into your account. And it's basically just an empty REPL that has the files in it that you need. So it's got like the Caterpillar file, it's got just.py, and you're going to use it. And what you want to do is type out these commands with one exception. All right, these are actually old notes, and get total pixels isn't a function that exists in the version we are using this year. So I forgot to change that, and I noticed it after I already handed out these note packets to one of the groups. So we're just going to update it here. So instead of get total pixels, if we want to know the total pixels, what that really is just the width times the height. So we're going to do get width a second time of picked, close those parentheses, times get height a second time, and then parentheses picked. All right. And that's what's going to go inside of your print statement. All right. So to get the total pixels, oops, it'd be helpful if I spelled height correctly. To get the total pixels, we're just doing width times height. All right. Get total pixels isn't actually going to work. So again, that's why I'm crossing that out. That's an old command that doesn't exist anymore. So if you try to write it, Python's going to give you an error and say, I don't recognize that function, and it's not going to work. So you want to write out these 4 lines and then use the results that you get to answer these questions. All right, so take a moment, do that, and then come back, and I will help you make sure that you got the correct answers. All right, so hopefully when you ran that, you ended up with a width of 329. You ended up with a height of 150. And when you multiplied those two things together, you should have ended up with 49,350. So when we're talking about the XY coordinate of the lower right corner, all right, remember 0, 0 is the top left. And then as you go to the right, X gets bigger. And as you go down, Y gets bigger. Now, if the width is 329, that means that the pixels go from 0 to 328. Because you're starting at 0, you don't quite get to 329. You stop one short. Same thing with this 150. Because you're starting at 0, you don't get quite to 150. You stop one short. So the coordinates of the bottom right would be 328 and 149. All right, how many pixels are there in each row? All right, so in each row, there are 329 pixels. All right, that's the same as your width. It's just that they're numbered 0 to 328. All right, in each column, there are 150 pixels. It's just that they're numbered 0 to 149. And then again, what is the total number of pixels? That's just this times this. So that is the 49,350. It's just the height times the width. All right. So again, the main thing to just kind of burn into your brain right now is this idea that yes, the width is this value. Yes, the height is this value, but that means the pixels go from 0 to 1 less than this. They go from 0 to 1 less than this when you're actually doing the coordinate piece. All right. If you try to go to coordinate 329, 150, you'll get an error because it doesn't actually exist. All right. All right, so here we have some more code that I would like you to type into that same REPL that you were just using. All right, so go to the console window, type all of this in, run it, and then I'm going to kind of talk through what's actually happening here. All right, but type this out, practice it. We're going to be using these commands a lot. You want to make sure that you're comfortable with them. So do take a moment now to type these into your REPL. Hit run. If there's any mistakes, try to find them. And then we're going to talk through what's actually happening here. All right. So this very first line, all right, we are using a function that's part of jest.py called GetPixel. All right, this is a function that requires 3 inputs. All right, the first input is a picture variable. All right, so, or a picture object, but basically you've created some sort of picture, you've given it a label. So this is referring, this has to be a picture. It can't be like a word or something like that. And then you're specifying the X coordinate and you're specifying the Y coordinate. So this is, again, a picture object, or you can think of it as a variable for right now. This is our X coordinate, this is our Y coordinate. So anytime you use GetPixel, you need to have these 3 inputs, and it needs to be in that order, right? P is just the name that we picked. I'm just creating a variable or an object P that is now going to be storing a pixel. So whereas this is storing an entire picture, this is going to store the information for just a single pixel. All right, so this is going to represent a single pixel that's part of this picture at these coordinates. All right, so this right here, get green, all right, you should end up with, I believe you get a 0 here, but this represents the green value. All right, so this represents the green value at pixel 111238. Right? We requested that pixel, we stored it in P. This is another function that only requires one input. All right, the input is a pixel. So we're sending this function a pixel, and then it's returning the green value at that pixel. All right, this is doing the same exact thing, only it's returning the red value. All right, so same idea here, but this, represents the red value. All right, so these, again, are functions that are part of that jest.py file that we're going to be able to use to interact and analyze pictures. All right, so this next one is just recording, is going to report the X and Y location of this pixel variable. So it should be no surprise that you ended up with 112 and 38 because those are the pixels that we requested. We requested the pixel at 11238. So if we say, hey, get the X and the Y value of that pixel, we're going to see that, oh, look at that, it knows its own coordinates. So what that tells us is that this pixel variable keeps track of its XY coordinates because we can access those, and it keeps track of its red, green, and blue values. We didn't actually do get blue, but it keeps track of those. So this pixel object that we've created, we can see that it knows it's red, it's green, it's blue, it's X, and it's Y, which is pretty much all of the important information for a pixel. We can do get X, get Y, get red, get green, get blue. When we create one of these pixel objects, and again, we created the pixel object by using this get pixel. It's the same way that back here, we created this picture object or picture variable by using make picture. right? This gave us a picture variable or object that we could use. Same idea here, right? GetPixel is creating this pixel object or variable that we can use. And then once we've created it, we're seeing that we can find out this information. We can find out the red value, the green value, the blue value, the X and the Y coordinate. All right. So this again is that same get red. The only difference is instead of just printing it out, we're creating a variable called value and storing the number 254 inside of that value. All right. Now down here, set red, this requires two inputs. All right, and those inputs are a pixel and the amount of red. So what this is going to do is it's going to go to that pixel P and change the red value of just that pixel. All right, so this whole line changes the red value of pixel P, and specifically what it's doing is it's doing 254 times 0.5 and changing it to 127. Right? And then if you do print P, you're going to see that it's, it gives you that message pixel at 112.38, which are the coordinates. And then it informs you that the red is now 127, the green is still 0, and the blue is still 0 because we didn't change either of those. All right, so in this way, we can access individual pixels in a picture and modify the values. And by modifying those values, we effectively modify the picture, right? Because the picture is just lots of these values sort of strung together. Now, this works for a single pixel, but we already saw that a pretty small picture still has almost 50,000 pixels. So we need a way that we can do this without having to go through each pixel one by one by one by one, because that would take forever, right? Enter the for loop, all right? This for loop is going to allow us to go through all of the pixels without having to specify them one by one by one by one. All right, so let's break down what's happening here so that we can kind of talk about how this is set up and what you need to know. All right, so for and in, these are both Python keywords. All right, so those are Python keywords that we use when we're setting up a for loop. All right, GetPixels is a function that returns, right? So that's like the answer that it gives back, a list, and a list is like a data object that we're going to talk about later in the year. But right now you can just think about it as a list of, like the same way we use lists as like humans, of all the pixels in our object picked, right? Because this is our object that we created, row by row. So it creates a big long list of every single pixel in our picture. So all 49,000 whatever pixels, it just puts in a list, and it creates that list by going across the row and then down, and then across the row and then down. So it goes over and then down a row, over and then down a row, over, then down a row. It doesn't go down the column and then over to the next one, or down the column over to the next one. It goes across the rows down to the next one, across the row down to the next one. So basically it goes this way when making the list, not this way. All right, so this is not the way that it goes. All right, it goes across when making the list. All right, but it's just a list of all of the pixels. All right, and then this is what we call our loop variable. All right, the P there is our loop variable, and we pick the name. All right, it didn't have to be P. I chose P because P is short for pixel. So what this loop is going to do is it's going to go through this list one by one, and it's going to assign each pixel to P. So the very first pixel is going to get assigned to P. This code is going to run. Then it's going to go to the next pixel, and it's going to store that in P. So P is going to keep getting wiped out with the next pixel. We're going to use it to do whatever code we want to do. And then once we're done with that code, we change it to a new pixel. Right? But they all run through this variable P that we created. And we just start with the first one. And when we're done with the first one, we clear it out and put in the second one. And when we're done with the second one, we clear it out and put in the third one. All right, so this right here, all of this, is the code that gets repeated. All right, so this is the code that gets repeated once for each pixel. All right, and again, as I was saying, in each repetition, P is the next pixel in the list. All right, so P just keeps getting the next pixel on the list so that we can keep modifying it and keep making those changes. Now, a couple of things. Notice the indentation, right? This has to be indented. This has to be indented. All right. Python knows when your loop is over when the indentation stops. So when you stop indenting, it recognizes that's the end of your loop, and that anything after the indentation can just be run normally. It's not part of the loop. It doesn't need to get repeated over and over and over and over again. Also notice that there's a colon here, just like we have when we do functions. These are all required parts of it. Otherwise, it won't work. And again, what's happening here is on the very first repetition, it's going to be looking at pixel 0, 0. Then when it gets to the second repetition, it's going to move on to pixel 1, 0, because the X is changing, but the Y is staying the same. We're going across. On the third pixel, it's going to be 2, 0. And then on the fourth pixel, it's going to be 3, 0, and so on and so forth. And eventually, when you get to the end of the row, all right, I'm just going to pretend that the end of the row is on the 21st repetition. Then you would finally go down to the next row and start over, and that would be at 0, 1. And then the 22nd one would be at 1, 1. and then the 23rd one would be at 2, 1, and you would just keep going through the picture again by going across and then down and then across and then down and then across and then down, pixel by pixel by pixel. So again, this is going to run this code that's just reducing the red, with that caterpillar picture almost 50,000 times, but it's going to happen so quickly that it's going to feel pretty instantaneous. All right, so what I want to do now is just sort of walk through one of these so that we've got a really good feel for what's happening. All right, so here's that same loop. All right, for P and get pixels picked, value equals get red, set red, P value 0.5. And then here's just like an imaginary picture. All right, so we're seeing that it's made up of 6 pixels, and each of those pixels have an RGB value. All right, so when the loop first starts, all right, this is going to make a list of all the pixels. The very first one is going to get assigned to P. So the very first iteration, P is going to be pixel 0, 0. The top left corner is 0, 0, which means value is going to be 255 because value is the red at pixel 0, 0, which from our picture here is 255. Now what the code is going to do is it's going to go and cut that value in half, which is going to change the 255 to 127. Now you might be saying, isn't it 127.5? Colors are going to be integers, so these color values are integers, so any decimals are just truncated. All right, they're not rounded, they're truncated, which just means that they're cut off, so it would give you a 127 there. It would not round up to 128. The 0.5 just disappears, and it's left as 127. All right, so that would be the first time through the loop. Once this line is finished, it loops back up, and then we go to the second iteration. All right, now we would be dealing with pixel 0, 1, right? Which is, whoops, sorry, not 0, 1, I apologize. Not 0, 1. We would be dealing with pixel 1, 0 because we move across the picture. So again, this is our X, this is our Y. So we're moving across the picture. Value is now going to be the red on this pixel, which is 100. And then when the code actually executes, this is going to get changed to 50. So again, P keeps changing. The first iteration, P is this pixel. The second iteration, P is this pixel. And we can keep going, all right? We can keep going and executing this out by hand, all right? On the third iteration, all right, we're still moving across our picture here. So this is going to be pixel 2, 0. All right, the red at that pixel is still 100. All right, so when that code executes, this is going to get changed to 50. And again, this is what P was storing on the third iteration. On the fourth iteration, all right, notice our picture was only 3 across. On the fourth iteration, we're then going to go down a row and start back at the beginning here. So that's going to be pixel 0, 1. All right. Now the value at 0, 1 is 255. And then when we cut that in half, we're going to get 127 again. And again, P just keeps moving and keeps changing as we go through this loop and as we go back up and back up and back up again and again and again and again. All right. So at this point, you should have a pretty good feel for what's happening. So I'm not going to go through the last two in as much detail, but it's the same premise. All right, P is going to move to this pixel. The red is going to get cut in half, which in this case doesn't actually change it at all. And then in the final iteration, P is going to move to here. This is going to get cut in half. All right, this in half would be 63 and a half, but the decimal gets truncated, so it's just 63. Now, again, you can't really tell the difference on a photocopy, but you should notice that all of these have sort of had the red reduced. And the only one that looks exactly the same is this bottom middle one, because red was already 0. So yeah, we did the calculation, but since red was already 0, the calculation didn't change anything. It's just put a 0 back in there. So from a color perspective, that one looks exactly the same. All right. Now, again, you can't really see this on a photocopy, but if you're looking at it on your computer, this picture has a blue-green tint because we reduced the red and nothing else. So we went through and just pulled out the red and created this blue-green tint on the picture. So if you think about it, sometimes like you'll see different like filters on, phones and things like that can like, make it look like there's a flag on top of your picture, or make it look like there's some like watermark type thing on top of your picture. What that's really doing is it's going through parts of the picture and changing certain colors to give it those tints. Now on this, we did it for the whole picture, but you could imagine like I could have just done this tint on like part of the picture. And then I could have done a different tint in this part of the picture. And then I could have done a different tint in this part of the picture and created that sort of like flag effect that you sometimes see with different filters. All right, so what we just did there, going through each of those kind of step by step by step, is called tracing, stepping, walking through the program. And it's where you kind of consider what each line of code would do, what each line of code would impact, and kind of execute it the same way the computer has to execute it. A lot of times as humans, we want to jump ahead and say like, all right, what would the end product be? But a lot of times it can be helpful to slow yourself down and say, all right, what is the computer doing each step of the way? And you consider exactly what's going to happen and what the computer has to execute. So again, sort of the process is considering each step of the program and the order the computer would execute it. You consider what exactly would happen, and then you write down the variables of you write down the values of each variable that it has at different points of the program. And it's one of the most important debugging skills you can have, which is basically sort of finding mistakes in your program. Because there are two kind of mistakes that you can make. One is the syntax mistake, where you mistype something or misspell something or use something that you can't use. And the computer lets you know. It will not run your program. The other type of debugging is when your program runs, but it doesn't do what you think it's going to do. You get an output that you were not expecting. And that's where this sort of tool can come in really handy, is walking through your program step by step and saying, oh, okay, I see now why I'm getting this answer when I thought I was going to get this answer over here, right? And it gives you that ability to sort of see what's happening. All right, so the last slide is just one more sort of debugging, tracing exercise. So I would encourage you to try this on your own. All right, you can then pause the video and I'll kind of walk through and explain it, but you should try it on your own first, right? You're not going to get comfortable with this stuff unless you're trying it on your own. Okay, so at the end of the first iteration, all right, so when we've done the first time through the loop, P is going to be pixel 0, 0, because it starts in the top left corner, all right? The R value, all right, so let's take a look at what the program is doing. It's recording the R value. It's recording the green value in separate variables, and then it's changing the red pixel to the green value, and it's changing the green part of the pixel to the red value. All right, so it's basically flip-flopping the red and the green. So at the start, our value is going to have, or even at the end, our value is going to have a 0. Green value is going to have a 255 because those are just being recorded in these variables. But then the pixel itself is going to be changed. All right. The 0 is going to be changed to a 255. The 255 is going to be changed to a 0. And this is the pixel that P is assigned to. So notice R value and G value didn't flip because there was nothing in our code that changed those. R value recorded the red pixel amount. G value recorded the green pixel amount. Yes, we used those to flip the red and green amounts in the pixel, but the values being stored in those variables never actually changed. All right, if we go to the second iteration, all right, this is 1, 0, right, because we're going over, not down. We go over first, so that means the X has increased, the Y has stayed the same. So the R value is going to be 255. The green value is going to be 255. P is assigned to this block right here. Now, these were reset. It's just they were reset to the same exact value, so nothing has changed. But we did execute code that changed the 255 to 255, changed the 255 to the 255. And then last but not least, right here, by the third iteration, we've come to the end of this row, so we have to move down to this next row. So that is going to be pixel 0, 1. The X is 0, the Y is 1 because we've moved down 1. R value is going to have the 100. G value is going to have the 255. Right? P is going to be assigned to this pixel down here. And then again, this one, since the values aren't the same, we are going to notice a difference. This one is going to go to 255. This one is going to go to 100. And then we didn't alter anything with blue, so that one just stays the same. So again, it's just a useful skill. It's helpful to think about it, and it helps you better understand the code that you're writing. Like, if you truly understand the code that you're writing, you should be able to go through it one line at a time and show me how different pieces are changing inside of your program. All right, and the only way you can do that is by having a full understanding of what each of these commands actually does. All right, so this is it for the notes here. And what this is going to now lead into is sort of your next lab. All right, so you got a little bit of this loop idea at the end of your first lab, and now you're going to go into it in a lot more detail and use it a lot more frequently in the second lab. So again, I hope this was helpful, and you can sort of use this as a jumping off point for lab 2. All right, have a great day.